Right now, what we want to focus on is um, right. So what we want to focus on. Remember that our maths is into 4 sections, and right now we are quickly going through all questions that do with shapes, all different types of shapes. We want to do them over and over again, and I'll be doing with you over and over again. I give you questions, and you're not going to let me down. So when I did for you the shapes, I showed you that you have 2D shapes, um, and I'm not going to do all of them. I'm looking at only one today that we haven't really talked about, and we want to master it. We have done 2D shapes, which are the plane shapes. And we know that the plane shapes, everybody can answer this. We know that for we already know the circle, the square, the rectangle. But do you know that the ones we really focus on at IGCSE level will be your parallelogram, and which is like this, and you have your kite, and you have your sector, which we were talking about a lot last time. We're doing questions on this. We'll do more on that, for obviously. And we were doing let me remove this. And we have a trapezium. These are the ones you should make sure you know, because they're not really talked about at lower levels. But we also have another one that we want to focus on today that can be tricky. So these are the plane shapes. We also have 3D shapes, well, which we're not looking at right now, are 3D shapes, which are the containers. But we are going to them, okay? We're going to them just now. 3D shapes are the containers, which are your cylinder, your sphere, containers that you can actually put something inside. These are the 3D shapes, okay? Then you have the sphere. Then you have obviously more and more and more cuboid. You have your cone, which is like this. Then you have your pyramid, which is really a square, right? With joints at one point. Right, so these are 3D shapes. Let me put them nicely. Draw it. We have our pyramid. So we have our cylinder, we have our pyramid, whatever. So we know that um this was a sector. This was the trapezium. This was the kite. This was the parallelogram, etc., etc. And here was the cone. This was the pyramid. And there are some tricky questions to do with cone and pyramid that I want to do. I want to do a lot of questions. And we're going to meet as we go past paper to past paper. Remember, we are doing it religiously. One to another, to another, to another, to another, and we are doing it religiously to make sure we are very good. Okay, we're going to do questions just now. So here I'm giving you a background so that you understand what we're doing before we go into the questions. Today we want to focus on a beautiful shape, a shape I really love, which is easy, and I need all of you to master it, and I'm going to do all the rules that come with this shape, all the different types of questions. And one thing I want us to agree on together is, guys, we cannot fail a triangle question. Guys, We can't fail a triangle question. A shape with three sides, students. A shape with three sides. Huh? How can we? Are we going to do that? No. No, we are not. We are not going to fail a shape with three sides. So let's get started. Let's see everything that we need to know about this shape that has three sides. Right. Let's go for it. Hello, Sibu. Please join for the lesson. Thank you. So if you do, and will write for me to say, there are three parts to know when doing triangles. If you if you want to master triangles, there are three parts to know. Right, let's go for it. And I want to do it and do the questions, hard questions. Okay. First thing that all of you must know, everybody in here should know how to get area of triangles. Triangles have only three sides. Come on now, guys. Surely, come on now. We're not going to struggle with a triangle. So the first thing we must know is how to get the area of a triangle. We must know that when we are trying to get the area of a triangle, I've done it with you before, so I'm just giving you real quick. First, you get a triangle. This is going to come in past papers. I know that it will. Okay? You get a triangle with a right angle. And a triangle with a right angle has base and it has height. Okay? So this is what you write. You need to write area is equal to base times height over 2. This is the first type of triangle you will get. Then there's the second one, which is like this, which could be like this. A triangle with no right angle. So we were seeing all the situations that you get where they may ask you to find area. We want to master everything until we get to sine rule and cosine rule. We're moving there right now. This second one is when you are going to be given this base and they'll actually put dots for you like this. They will, and put a right angle like this. That's what they'll do. This is your height. And I want you to know, to get the area of this, you also will say base times height over 2. Then you will also get a triangle like this, the third one. Then you have here A, you have B, you have theta. Area for this one, they won't give you base, they won't give you heights. This is the third situation you may meet. It's coming. One of it is coming, and I want you to call me, sir. They gave us this. They gave us this area. They gave us this in the exam. Obviously, say I did it correctly. I'll be happy. Of course, I'll be happy. That's why I'm preparing you like this. This is the third situation which you may get for this triangle. We want to finish this shape forever and ever, people. For this one, you say area is you take this side, which in this case we are calling A. Then you take this other side, which in this case you're calling B. You multiply them. Then you multiply by sine theta, sine of this one. Then you divide by 2. Okay, everything is divided by 2. Look, this area is base times height over 2. Here, base times height over 2. Here, AB sine theta over 2. So everything is over 2, over 2, over 2. There we go for this shape. Right. Right. So here, let's go to the second thing. So for area, we are done. Let's go to the second thing. This is right angled triangles. And this is, I'm just giving you the two rules in passing. This is now not area anymore, but missing sides or angles. Missing sides or angles. Right. This is a right angled triangle. And we have missing sides or angles. Right, so what do we do here? Here's what you do when you're doing this. Okay, then we go to the non-right angled, then we do questions, and you're not going to change anything. So listen closely, let's close it off. What you do here is you always test, okay? When you're doing a right angle triangle, remember, there are two methods. Method number one, for right angle triangles, there are only two methods, okay? I hope you're not a boring student. Listen to me closely so that you do what I've taught you. Pythagoras theorem is the first one. So let's go. Pythagoras theorem. Then the second one is SOHCAHTOA. So what you are going to do is you get a question, okay? You get a question. Let's do for the first one, Pythagoras theorem. You get a question. You always check Pythagoras theorem first. Pythagoras theorem. Try this first. When you get a triangle that has a right angle, you try Pythagoras theorem first before you go to SOHCAHTOA. Okay, I'll take you to sine rule and cosine rule and show you what you also do there. So let's finish it here. What you must know is, for a triangle, let's do one. Here is what I want you to do, and let's finish it. You get a triangle with a right angle. Listen to what you do closely. You get a triangle that has a right angle, right? Now, 3, 5, and this triangle is called ABC. Then they say, find side AB. This is case number one. So, this is a triangle, a shape with 3 sides. We are mastering it. So what we are saying is that as long as it has a right angle, the first thing is we test if we can use Pythagoras theorem. Pythagoras theorem, it works when you have 2 sides and one side is missing. This is when you use Pythagoras theorem. So you're going to test it so that you use it. And you already know that you use it when you have 2 sides and one is missing. So I will look at this one. In real situations, they won't say, okay, guys, now we are doing Pythagoras theorem. Okay, guys, now we are doing SOHCAHTOA. Remember, we are doing past paper questions. We are in exam season, so we are not wasting our time with easy questions, okay? But I'm preparing you for procedures that you must follow in a past paper situation. This shape called a triangle, you realize, oh, this is a triangle. And you see, oh, it has a right angle. So please check for me, does it have 2 sides? Can you see 2 sides that you are given? Oh yes, this one I'm given and this one I'm given. So I have 2 sides. Now check for me, are they asking for a third side? Yes, they are asking for a third side. Find side AB. So they are asking for a third. Oh, so this is Pythagoras theorem. So you write, this is Pythagoras theorem. Okay, everybody can see this is a Pythagoras theorem question, so it ticks. Okay, we know that once you see a right angle, either it is going to be, you write with your pencil, either it is going to be Pythagoras. If not, then it will be SOHCAHTOA. So you write with your pencil because you've seen a right angle. Now you check, do I have two sides? Yes. Are they asking for the third one? Yes. So it's Pythagoras. So SOHCAHTOA is out. Now, what does Pythagoras say? Pythagoras says three things. What does Pythagoras say? It says three things. What are the three things that Pythagoras says? Number one is make sure hypotenuse is alone. Hypotenuse should be alone. Okay? This is the Pythagoras theorem. Write it for those who want to write Pythagoras theorem. Hypotenuse should be alone. That's number one. If you're doing the true Pythagoras, then the second is the other two sides must add. Then the last rule, let's do it quick before we go to the past paper questions. The third rule is that all sides should be squared. All sides must be squared. If you do this, then you have written the Pythagoras theorem. So you identify, I said, look at your triangle. Okay, we are mastering it. Look at your triangle. Yes, sir, I'm looking at the triangle. Do you know two sides? Yes, sir. Are they looking for the third side? Yes, sir. So you use Pythagoras theorem. Now let's use it. We have agreed that we use Pythagoras theorem. Now let's use it. And we know what it says. Hypotenuse alone. The other two sides they add. Then all sides should be squared. So let's make hypotenuse be alone. It should be alone. Choose the hypotenuse. Hypotenuse is the side opposite the corner, okay, of your right angle. Opposite the corner. So this is our hypotenuse in this case. In this case, our hypotenuse is 5. In this question. Hi, Michelle. You can't see my screen. Okay. Can the others see my screen? Okay, let me help quickly. So you all, yes, hi, Christian. You can ask me a question. I see your hand is up. Can you see my screen? Wait, let me fix it. Let me fix it. Right. Okay. So everybody, there we go. Let's do it now. Hypotenuse, we have found it. We have identified it. We know that it must be alone so that we can find the missing side. So hypotenuse should be alone. 5 is alone. And make it squared. Remember, all sides should be squared. Then it is equal to the other two sides must add, which is going to be 3. And it must be squared plus this other side here, which is AB, okay, which you also square. Okay, the other two sides must add. You see they are adding, and you see they are all squared. So you have done the correct Pythagoras theorem. Well done. You have done the correct Pythagoras theorem. Now you're just left with now solving. This is the correct Pythagoras theorem. We do second step, which is now solving. And to solve, we take this to the other side. We will now have 5 squared minus 3 squared, okay? Because it was adding. We take it to the other side now. Then it is equal to AB squared. But the Pythagoras theorem was this one. This is the Pythagoras. This is the correct one. The reason you get the correct answer is you did the correct Pythagoras. A lot of people do the wrong Pythagoras. So they get it wrong, obviously. So now you have it correct like this. All you have to do is get your answer. 5 squared, 25, minus 3 squared, 9, is equal to AB squared. 25 minus 9, 16, is equal to AB squared. Then you take squared to the other side, it becomes square root. Okay, this power of 2. You take it to the other side, it becomes square root of 16. It's now equal to AB. Now AB is alone. Square root of 16 is 4. 4 is AB. The reason we didn't put plus or minus is we are dealing with lengths, so they can only be plus. So our answer is 4. So if it was centimeters, 4 centimeters is your AB. If it was meters, 4 meters is your AB. This is the Pythagoras. And you test it first. You get a question and you see a right angle, test to see if Pythagoras works. How do you test to see if Pythagoras works? See if you have been given 2 sides and they are asking for the third side. Then you use it. Any other situation, B, you have to use SOHCAHTOA. So SOHCAHTOA is written like this. SOHCAHTOA. It is used for all situations involving a right-angled triangle. All situations that involve a right-angled triangle in which Pythagoras theorem cannot work. In which Pythagoras theorem cannot work. So Pythagoras theorem, if it can't work, automatically you do SOHCAHTOA. Let's do situations. 2 questions real quick and you'll be done. Let's do 2 questions real quick. Three, 5, then we can say theta. Okay, or even if they say A, B, C, then they say find A, C, B. Find A, C, B. Find A, C, B. The angle at C. Now, I'll ask you a question. Can Pythagoras theorem work? Look at this, students. Check. Do you have 2 sides? Oh, yes, I have. I know 3, I know 5. Because you see, does it have a right angle? Yes. Do you have 2 sides? Oh, yes, sir, I have 3 and 5. Okay, good. Are they looking for the third side? No, sir. So Pythagoras can't work. They are not looking for the third side. So Pythagoras cannot work. So when we see a right angle, right? When we see a right angle with our pencil, we are smart. We know that there are only 2 methods that work for this one. We know triangles. Triangles, we know them. We are good at triangles. When we see a right angle, we write Pythagoras and we write SOHCAHTOA. One of them will work because it is a right angle. All the other methods don't work here because it has a right angle. So we write Pythagoras and we write SOHCAHTOA. Now, can Pythagoras work? No, it can't. So automatically SOHCAHTOA. Because we have 2 sides, but we are not looking for the third one. They want ACB, which is angle. Which is the angle. At the angle at C, that's where the thing is. So they want this one. So we'll come here and we'll put it as theta. We'll come and put it as theta. Now, we can go on and answer now. Because what we would then do is, we know we are now using SOHCAHTOA. For Pythagoras theorem, when we saw we were now using Pythagoras theorem, we looked for hypotenuse. Once we had hypotenuse, we wrote the Pythagoras theorem. Here we write SOHCAHTOA. Then we start labeling according to SOHCAHTOA. Let's label according to SOHCAHTOA. Opposite the right angle is the hypotenuse. That will never change. Opposite the corner for right angle is hypotenuse. But now we have other sides as well. Because opposite the angle, we now call it the opposite side. The side which is opposite the angle. Okay, you always go opposite the angle. If the angle is here, you are going to do this. But it's down here, so you go up. Then the third one is adjacent. So we have opposite, we have hypotenuse, we have adjacent. You put it in brackets nice and soft. Now, well done. You have labeled. So what was the first step? Follow the steps, master the steps. The first steps was to check if it's Pythagoras or if it's SOHCAHTOA. And you have seen that it's SOHCAHTOA. Now that you have seen it's SOHCAHTOA, your next step is to label your triangle. Now that you have labeled your triangle, your third step is to now look for a useless side. For us to use SOHCAHTOA, we need to identify the useless side. We need to find the useless side. Give me a second, everybody. Need to fix. Right. Give me a second. Okay. We say that we need to find the missing side. Can you hear me? Antonisha, can you hear me? Good. So we need to find the missing side. The useless side, rather, not the missing one, the useless one. A side which you are not given, and the question didn't even ask you to find it. The side which is none of your business. The question didn't ask you to find it. You are not even interested in it. It's useless. Which side is it this time? It's adjacent. We don't know what value it is because we know opposite, we know hypotenuse. Adjacent, we don't even know it, and they didn't even ask for it. So you go to your SOHCAHTOA and cancel everything with adjacent. Ka and toa, they have adjacent. So that means for this question, students, you have to use so. If you want to get an answer for this question, you have to use so. What does so mean? S means sine. So you say sine theta is equal to O means opposite over H means hypotenuse. So this is what you now write for Cambridge. All this you do with a pencil, but for Cambridge, you start here. This is what you're going to submit to Cambridge. Because now what you would then say is sine of my theta will be equal to, what is the opposite? 3 over, what is the hypotenuse? 5. Now to find theta, you got to take sine to the other side. Theta will be sine inverse of 3 over 5. What is that going to be? What is theta going to be, students? Second function sine, then say 3 over 5. What is the answer? Put it in the chat. Put it in the chat. Everybody, I want to see the answer in the chat. Come on now. Where are the calculators today? Are you hiding them? Put the answer in the chat, guys. Second function sine 3 over 5. Put the answer in the chat. I want to see the answer. Simon, I want to see your answer. Michelle, can you put the answer in the chat? Second function sine, you put 3 over 5. Let's go. Everybody put your answers. Put it more in full. Come on now. Letty, where is the answer? Kelly, tell me the answer to this now. Put it in the chat. Put it in the chat. 36.869. 36.869. Yes, keep them coming. Lehako, what is your answer? I haven't seen it. Where is the answer? Seth, where is the answer? I haven't seen it. Sarah, what is going on? Wandipa? Mazvita? Why are you not punching, guys? Please, can you keep your hands moving? Wandipa? And Tima. Punch, punch, punch. 36.869. 36.869. 36.86. 36.869. So if it's 36.869, it's 36.9. Okay, this is going to be your value. We good. 36.869. We round it off because they want one decimal after the comma. So it's 36.9. Well done. If you want first, write 36.869 or something, which is 36.9 degrees. You need to put the degrees on. So this is going to be your theta. So and this is your ACD is equal to this. You get your marks. This is what you do. You tested Pythagoras. It didn't work. You used SOHCAHTOA. It worked. You got your answer. Then the last example before we move to the last section of triangles and we know we're done. The last example is this one. This one. Then they say find side BC. This is going to be this, excuse me. This is going to be the third one, the second example. So, you are in an exam setting, okay? We are practicing procedure. You see a right angle on your triangle. Triangles, we are not afraid of you. You see a right angle, you write quickly Pythagoras. And you write SOHCAHTOA. Then you tell them, one of you is going to work here. How do you know? How do you know? I know. Maths can never be broken. The rules of maths, once you break them, you are gone. They can never be broken. These are the only ones that work here for this situation. They were made, these rules were made for right-angled triangles. So you check, can you do Pythagoras? That's what you check. It's easy to see Pythagoras. Do you have two sides? Look here, you actually have one. For Pythagoras, you must have two sides and looking for the third one. Here you actually just have one. So obviously Pythagoras is out. SOHCAHTOA becomes the one. Now you have chosen the method. You need to label your triangle. You have chosen the method, label your triangle. Opposite the corner of the right angle is the hypotenuse. This is the hypotenuse. Opposite the angle is the opposite side. The third one is the adjacent. So you have hypotenuse, opposite, adjacent. Well done. Now, again I ask you, you have labeled your triangle for SOHCAHTOA. You are ready for it. Please find for us which side is useless. It's not even part of the question. Okay? Let's change the question so that we do something different this time. Let's say they say find AC. Can you change it to AC? People, change this one from BC to AC. They say find AC. Everybody, please change it to AC. So you want side AC? Yes, it is this one. Side A. So, okay, which side is not involved in the question? It's obviously hypotenuse. We have not been given him, and they didn't even ask for him. So he is not in the question. Hypotenuse is out. So everything with hypotenuse we remove. So and ka, we remove them because they have the useless side. Remove them. Oh, now, so how do we get the answer? To get the answer in this question, you have to use TOA. So you now can use TOA. What is T? T is tan. So tan theta is equal to, what is O? Opposite. Over what is A? Adjacent. This is what you start giving Cambridge. You start by writing this. Then now, since you are looking for adjacent here, the A, you are going to swap it with tan theta. You now have adjacent will be opposite over tan theta. You swap it like You swap them. Which is going to be, what is the opposite? 3 over tan. What is theta? 40 degrees. What do you get for adjacent? Which is your AC. Side AC. What do you get for side AC? What is 3 divided by tan 40 degrees? Tell me, students, don't let me down. What is 3 divided by tan 40 degrees? Put the answers in the chat. Let's go for it. Come on now. Seth, I want to see your answer this time. Simon, I want to see your answer. Okay, bring them in. Bring them in. Clive Bondi, let me see your answer. LGK, please rejoin. What happened? Okay, restart it and try again. Oh, 3.575. Good. Which you can put it as 3.58. Centimeters, if it's centimeters, or whatever. Centimeters, if it's centimeters, you can write your 3.58. Okay, so this one is 3.58 centimeters. We are done with right-angled triangles. We don't fear them. There's no way we can fear them. Triangles, man, you are nothing, sir. We don't fear you. We go to the third section, students, which is non-right-angled triangles. Non-right-angled triangles. Non-right-angled triangles. This time we are not getting area. We are looking for missing side or angle. Okay? This time we are not looking for area. We are looking for a missing side, or we are looking for a missing angle. We are looking for a missing side, or we are looking for a missing angle. Right. We're looking for a missing side, or we're looking for a missing angle. Let's go. Not area. Let's see how we do this one. Right. What you're going to do is, okay, remember for this one, if you don't see a right angle, you change your thinking and you should write that there are two methods you can use. There are two methods you can use. Everybody, keep paying attention. Stay around. There are two methods you can use. One, sine rule. Then two, cosine rule. Nothing else. These are the two methods that you can use. These are the only two methods you can use. The sine rule or the cosine rule. Right. Let's see. What you do is, look at what you do. You get a right angle triangle. So let's do it here. Or let me write here to say, always test or always check to see if you can use cosine rule first. Always check to see if you can use the cosine rule first. Always check to see if you can use the cosine rule first. Right. And write for me this. Cosine rule is used. One, for included angle. Okay, or say, if there is an included angle. We're going to talk about it. Or two, if you have all three sides. If you have an included angle, or if you have all three sides, then write for me to say, anything else, use the sine rule. Anything else, use the sine rule. Right. Let's do cases. So for sine rule, you actually don't have to know anything. Just see if cosine rule can work or not. If cosine rule can't work, automatically it's sine rule. Let's do the cases. Number one, you get a triangle. It's like this. Then you are told that this is 5, this is 12, this is 30 degrees, and it is triangle X, Y, Z. Then they say, find X, Z. Then they say, find X, Z. So what do you write? You write here, does this triangle have a right angle? No, it doesn't. So what methods do I have? With a pencil, you write cosine rule, and you have the sine rule. One of them is working here. Now, let's check for cosine rule. We said cosine rule works if you have included angle or if you have all three sides. What is an included angle? An included angle is an angle you are given, and that angle that they give you, you will be knowing the two sides that come and meet at that angle. So you should know the angle. So the angle you'll be having, right? When you get an angle, check if it is included. If it's included, it means you know the two sides that come and meet at that angle. Here we know them. We know 5 and we know 12. They meet at the included angle. So because we know them, this is an included angle. They meet at angle 30. So it makes angle 30 be an included angle. Angle 30, therefore, you are an included angle. So because it is an included angle, angle 30 degrees is an included angle. Great. Now we use cosine rule. So you can say this is included angle. So it meets the conditions for cosine rule. Now, how do we do the cosine rule? What does it say? It says when you're looking for a missing side, this one, xz, you say xz, the side you are looking for, all squared, it is going to be equal to, you take this one, you write first like Pythagoras, okay? You are looking for xz. That's the one they want. They said find xz, which is this one. This side. Xz all squared is equal to, you take this one, you square it, 5 squared, plus you also take this one, you square it, 12 squared. Okay? You add them whilst they are squared. So when you are adding, they will be squared. Then you subtract and open a bracket. This is what cosine rule then says. You subtract and open a bracket. Then you bring back 5 and 12. But now they are no longer squared. Okay? And they are multiplied. But you should be saying minus 2 times 5 times 12. You bring them 5 and 12, but they have a 2. I almost left the 2. Minus 2 times 5 times 12. You bring them again. They are no longer squared. And then they will multiply cos of the angle, which is cos 30. This is how you do it. Raise your hand if you want me to write it one more time. If you want me to write it one more time, raise your hand. Oh, Lusaka, you can't see the screen. Try to quickly rejoin. Let's see, Lusaka. Everybody, try to quickly rejoin. We want to just master it on this Wednesday, 8 July. Want to make sure all of you are good. Okay. Let me give it to you. Okay, I can see there's a question here. Hello. Right. Can we use calculus to find? No, not for IG. Don't use calculus. Okay, so what we'll be saying is let's do. I'm seeing the YouTube chat. Hello, everybody on YouTube. Put your names. Let's see. Look what you do here. Let's go for it again. Cosine rule. What do you say? I've seen the included angle. It's an easy one. It's an angle, and you know the two sides that meet at the angle. So when you see that situation and you're looking for a missing side, use the cosine rule. But how do I write the cosine rule? Let's write it again. It says you are looking for xz, right? So it says xz, you must square it. It is equal to these two sides also squared, and they should be adding, not multiplying. When you square them, they should be adding. When you square them, they must be adding. But you then say minus after adding them. You say minus and open a big bracket, which will take 2. People sometimes forget the 2. 2. Then you bring the sides again, 5 and 12. Okay? And they are no longer adding, they are no longer squared. They are just multiplying, 5 and 12. Then you now say cos 30 degrees. That is why it's called the cosine rule, because it has cos in it. So, can somebody first punch this and tell me what you get for xz squared? What is this? Can you punch it exactly as it is? Can you all punch it exactly as it is and tell me? Yes, Abdullah's a man. I'm checking your comments. Can you tell me what answer this is? Punch it like this in the calculator. Let's see. Students, can you put it in the chat? Antonisha, Hope, can you put it? Let's see. Please put it exactly like this. Seth, can I see your answer, please? Simon, can I see your answer, please? Good. So you get, don't round it off. Give me the big one. 65.07695. Something like this. So now to get xz, you now square root because this was xz squared. Remember, this was xz. Hi, Simon. Please join class. Okay, okay. Do it. So you take power of 2 to the other side, it becomes square root of 65.0769. Is it 07 what? Let me check the chat again. Let me see what answers you gave me. 65.07695. So you put square root of this. What do you now get? Can somebody do square root of this and tell me what you now get as your answer? Can somebody do square root and tell me what you now get as your answer? Can you now do square root and tell me what you get as your answer? Bring the answers, bring the answers. Students, what's wrong? Aki, can I see your answer? 8.067. Okay? Answer becomes 8.067. 8.07, 8.06. Yeah, 8.07 is also good. It's also realistic. You get your marks. If it's centimeters, you can say centimeters or whatever. Usually they want it to 2 decimal places, so you can say 8.07, which means you say it is 8.067, which you make it 8.07 centimeters. Okay, photography by kids. I see your comment. Here is this is the one. Now, listen, students. Let's do the second situation. I want you to practice this part here. You watch it over and over again. This is the cosine rule. So let me tell you what people think out there, okay? People who make mistakes. They think that the cosine rule is the whole working which we did all the way until we got to the bottom. That's a lie. Cosine rule is not all the working until we got to the bottom. Cosine rule is just this part only. This one. So if you are practicing the cosine rule, you are practicing writing this first part. Then afterwards, you'll be now solving. So it's no longer the cosine rule. Cosine rule is this one. So if you want to practice the cosine rule, I'm showing you right now, the one I'm underlining. That's the cosine rule. Everything else is now just finishing it up. Okay, just like we saw, the Pythagoras theorem was just this one here. This is not the whole thing. So if you're practicing Pythagoras, you are practicing how to write this one, which I'm highlighting in blue, correctly. Then resolving and finding this is the second step. That's another step. So what about if they give you this? Okay, we are almost done. We are just left with 2 situations and you are done with triangles. Okay, we would need past paper questions to test us. To see, are we correct or are we not? 5, 12, 15. This becomes theta. Or even if you say ABC, then they say find angle ABC. Find angle ABC. Find angle ABC. Find angle ABC. Right. Now, students, when you see this triangle, look, don't jump steps. You see that this triangle does not have a right angle. So, if it doesn't have a right angle, then you write for me quickly sine rule and you write cosine rule. These are the rules that work. If it doesn't have a right angle, we use one of this. Now, check the situations for cosine rule. Cosine rule is two situations. One is you have an included angle, which means you have an angle that you are given. Let's say they give you this to say 20 degrees. If they give you an angle and you know the two sides that meet at that angle, then you have an included angle. If you look here in this question, they didn't give us an angle. So we can't say there is included angle. Where? You didn't get an angle. Okay, all right. Now you check the second thing. Are you given three sides? Oh, yes, you're given three. Oh, so here we use cosine rule again. Here we use the cosine rule again. Again, yes. Let's write it and let's see if we now know how to write it. Because we have to use it again. What does the cosine rule say? This side here, which is opposite your angle, okay? You write it as squared. The side 15, which is opposite our angle, we write it 15, we write it as squared. So you write 15 squared. It is equal to these other two. Okay? It's equal to the other two, the 5 and the 12. And they'll be squared and adding. They will be squared and adding. So the one which is opposite your angle is alone. Okay, it's squared. These other two will be squared and adding. Then you say minus. You say minus. You say minus. Minus, yes. What do you say? Open a big bracket. You say 2. Then you bring back this 5, but it's no longer squared. Then you bring back this 12, but it's no longer squared. Then you now say cos theta. So practice the cosine, this. Practice writing it. The side which is alone is squared. These other two, you bring them as squared first, adding. Then you say minus, you open a bracket. Then don't leave this 2. Start with the 2. People always forget the 2. Start with the 2. You say 2, then you bring 5, then you bring 12, then you say cos theta. Now, in this situation, we need to find this cos theta. We need to find this cos theta. So what do we do, sir? How do we find this cos theta? You do only 2 things to find it. You want to find cos theta, you do 2 things, okay? So that you can find the theta. You swap it, because it's negative, It's negative. So you swap it with 15 squared, because it's negative. So it will come as a bracket, okay? 2 by 5 by 12 by cos theta is equal to 5 squared plus 12 squared. They are still adding this 2. Then 15 goes to subtract. Hey, 15 goes to subtract. It's a 15 squared. It goes to subtract. So you take this bracket, it swaps with 15. It's now positive, 15 is now negative. So you have it like this. That's the first step. Then the second step, after swapping the whole bracket, the second step is you now take these 3, they go to the other side, and they will divide. Because they are multiplying here, so they will divide. So you remain with cos theta. This is now working out. It's not the cosine rule. Cosine rule is just this first step. I'm teaching you how to now work out. So you take 2, 5, 12 to the other side. they go to decide. So you have 5 squared plus 12 squared minus 15 squared divided by 2 by 5 by 12. Well done. Let me tell you what will make me happy. I'll be happy if my students can write the cosine rule, this one. Because if you can do this one, then every other step is going to be easy. So this is where it will be hard. Write the cosine rule correctly, then everything becomes easy. So you have it like this. You can punch it in the calculator. Tell me what you get for cos theta. Tell me what you get. Open bracket, students. You open a bracket. You say 5 squared plus 12 squared minus 15 squared. You close the bracket. You say divided by. Then you can open a bracket and say 2 times 5 times 12. Close bracket is equal to. Punch it, or you can punch it the way I've just put it right now with the brackets there. Punch it like this. Tell me what answer you get for cos theta. Bring the answers. Bring the answers. Come on, students. Bring the answers for cos theta. Tapelo, I want to see you answer. Bring the answer. Put it in the chat. Students, put it in the chat, everybody. What is the answer? Put it in the chat. Okay, good. Good. Don't round off yet. Don't round off yet. Don't round off yet. Are you getting exactly 117.8? Everybody? Hello? Simon, what are you getting? Put the answer in the chat. Pakiso. Kingsley. Kosi. Can I see your answers? Kingsley. Kosi, can I see your answers, please? Simon? Okay, Kosi, well done. I can see. Sarah. 117.8. So, you now say theta is cos inverse of 117.8. You now get your angle. So, let me tell you, if you just change the approach, this question which we have done is going to become hard. You see, right now it looks easy. It's because we follow the correct approach. What we did was, we saw that we have a triangle. Then we looked at it. We said, does it have a right angle? Yes or no? We saw no, it doesn't. So we quickly wrote sine rule, cosine rule. Then we checked, does it fit for the situations for cosine rule? We saw that it does. It has 3 sides. So we used cosine rule. So we did the cosine rule nicely. Then we looked for the missing angle and we are done. What is the answer here? Cos inverse of 117.8. What is the answer? Mathematicians, what is the answer? Second function cos 117.8. What is the answer? Bring in the answers. What is the answer? Second function cos 117.8. What is the answer? Do my students know how to do it? What did you get? Really? What answer did you get? Okay. Cos theta should not actually cos theta should not be above 1 or something like that. So something is wrong. What are you getting? What did you get? You got negative 0.4. Yes, Hope, what answer did you get? Oh, oh, okay. Now, now it's beginning to make sense. So when you got all the answers, that's the final solution. You had done everything in one go. So let's do it. Let me do the fraction. Let's see, everybody. 5 squared plus 12 squared plus minus 15 squared over 2 negative 0.4667. Wow. So when you guys were saying 117.8, it was your final solution, not this. Okay. So theta will be cos inverse of negative 0.46667. What is the answer? 117.8. Is that when you got 117.8 degrees? Okay. Yes, because the degrees should be to one decimal place. Okay. All right. Okay. Well done. Now let's do one last one. And you know you're done with triangles here. 30 degrees, 5, 45 degrees. I'm just creating A, B, C. Then you say, find AC. It may be also different from the one I'm writing right now. They can change something, but what I want us to do is, what is the first thing you check? Simon, the first thing is you see this triangle, you say, ha, it has no right angle. So either I'm going to use the sine rule, or I'm going to use the cosine rule. Now, check. Do you have an included angle? You see, I've been given angles. Let me see if the angles I've been given are included. We check 30. Is it included? Do I know this one? No. Do I know this? So it can't be included. Let's check 45. Is it included? Do I know this one? No. So it's not included because I only know one. I need to know both. So included angle is not there. Okay. Do I know all three sides? No. Cosine rule, you're out. I can't use you for this. So, students, we are left with one rule, sine rule. Oh. This has to be the method. Don't say I didn't train you. I have trained you. Now, here's how you do the sine rule. Sine rule says it like this. So, first you must see the letters that you have, okay? If you want to do the sine rule, you must see the letters you have in your question. It could be A, B, C, it could be X, Y, Z, it could be M, K, N, they bring some letters. It could be anything. So in here, it is A, B, and C. So it's the easy situation. So what you do, sign rule says this. Sign of A, when you put it over small a, should be the same as sign of big B over small b, which should be the same as sign of big C over small c. So it's something like this. Sign big A over small a. It's for these letters. We have A, B, and C. So we use the sign with A, B, and C as well. Big A is on sign. So it's sign big A over small a is equal to sign big B over small b, which is equal to sign big C over small c. Now, what is big A and small a? Big A is the angle. Small a is the side, which is opposite big A. Big B is the angle. Small b is the side opposite it. Big C is the angle. Small c is the side opposite it. So we write it like this. You have decided to use the sign rule. You write this, then you label also. Small c, small a, small b, like that. You do it like that. All right. Now, sign rule works like SOHCAHTOA. When you write it like this, there is no way on earth that you can have a question in math with two equal signs. Where have you seen anything in maths with two equal signs? Tell me, where? So when we write the sign rule like this, it's for notation. That's why you see I didn't write it here with the pen, okay? This is done with a pen, so it's for notation. We don't do anything with two equal signs and say it's maths. What kind of maths is that? Huh? What type of maths is that? So it's just the notation. What you are supposed to do after writing like this, you write the sign rule, right? You chose the sign rule because cosine rule was not working. You chose the sign rule. You labeled the small sides. Now what you are supposed to do is cancel the letter which is useless. Everybody can see that here we do not need C. C is useless. We don't have the angle at C, and we don't have the side. So you cancel one way, you don't have the angle, and you don't have the side. For big B, we have the angle. We may not have side small b, but we have the angle big B. For AE, we have both, so obviously C is out. So we go to our sign rule, we remove C. So the one we write for Cambridge is supposed to have A and B. Sometimes it can have A and C. Sometimes it can have B and C. It just depends. So here it has A and B. So we now write sine big A over small a should be equal to sine big B over small b. Now, everybody can see that we are looking for small b because that's the side AC. Side AC is small b. So what do we do when we are looking for it? Because it's in the denominator, we can't find it. So we have to flip. Okay? If what you are looking for is in the denominator, you flip, but you flip both sides. Small a over sine big A is equal to small b over sine big B. You flip both sides. Well done. You are doing some seriously good maths. Then you can take sine big B to the other side. You now have A over sine big A times sine big B. Because when sine big B goes there, it will now multiply. Since it was dividing, it is equal to small b. Then we can now put it. What is our small a? 5. You say 5 divided by sine of big A. What is big A here? 30 degrees. Sine of 30 degrees. Times sine of big B, okay? Big B. And what is big B in here? 45 degrees. This is equal to small b. This is equal to small b. And our small b is the AC. It is the AC. So punch. You can punch one time and get an answer. Sine rule, that's the good thing about sine rule. You can punch it one time. Say 5 divided by sine 30 times sine 45. What do you get? 5 divided by sine 30 times sine 45. One time, just punch. What do you get? Can I get answers, please? Yes. 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 I know what you mean. I know what you mean. The reason that happens is that the reason that happens, LGK, is when people try to do, there is a different version of cosine rule that people try to do. Okay, Lehakwa? Uh, which has a shortcut. There's a different version of cosine rule that people try to do that has a shortcut. If you do this one, you are never going to make that mistake. Remember, when you do cosine rule, you have to practice it the whole night if you need to. The guy opposite your angle should be squared. Then you say equal to, you add the other two squared whilst adding. Okay, 5 squared plus 12 squared. Then you subtract, you do these other two again, but you multiply them by 2. This is the dangerous one, these 2 inside the. People forget it. Trust me. I'm not lying. I'm telling you the truth as my students. You say minus, you open bracket, you say 2, then you say 5, 12, then cos theta and close. If you start like this, LGK, you will not make a mistake. You will not make a mistake. Write the cosine rule correctly. If you're looking for theta, you swap it. You take this negative to the other side. 15 squared will come to this other side. Remember to swap. That is after writing the cosine rule. You swap. Then after swapping, you take these guys to the other side to divide. Then when they divide, you get your cos theta. Then you take cos to the other side. You get your theta. You are done. That's some very good mathematics here. And if you people use them, we are going to have a great squad. Is everybody with me? Good. Remember, test cosine rule first. Do you see included angle? Do you see 3 sides given? If not, then you use the sine rule. So you tick sine rule. Check the letters you are given and create sine rule for yourself. You write sine A over sine B over small, sine C over C. Then put the small letters. After putting the small letters, then look for the useless one. Remove him, do the correct sine rule, finish the question, get your marks. 4 marks, it will have 4 marks, it will have 3. Sometimes you can do a cosine rule with so many marks. But how will you get it correct all the time? The procedure. If you guys break the procedure, we are in trouble. Mathematics is an art. If you want to draw your face, you have to know, what do you start with? Do I start with the cheekbones? Do I start with shading this? If you reverse the order, you get the wrong thing. So, same as math. Do it this way, do it correctly, get your marks, move on to harder things next year. Right. Are we together? Wow. We've taken a lot.